Hi everyone, my name is Sadashiv and this is VitalSync, a clinical intelligence platform. We have Next.js on the front end and Nest.js on the back end. We also implemented the type ORM and JWT authentication, PostgreSQL on Neon, right? Back end on Render and front end on the Vercel, of course. So let us quickly understand the full auth pipeline where we understand the password hashing, JWT, issuance, and role-based route protection, right? So first comes the registration. I'll register myself as Dashiv, or let's say Shiv. So let's say create gmail.com. The password is 1 2 3 4 8. Right. So here my user entity separates the authentication data from profile data. Email, name, hash password, and a role of either doctor or password live in users table. So doctor specific and patient specific fields live separately in our tables. Uh, so we can see that we have two tables that separate the data. So now here you can see there are 14 users, right? So when we register, we should get another user added in the users table, right? So when I create register myself as doctor, right? So we have been registered, and now when I refresh it, I should see my user being updated. So we got it over here. Also, you can see that the password I just entered is not plain text. It is hashed one using the bcrypt JS, and we have the hash password. So that's how the hash column password hash column works. We use 10 salt rounds. So the plain text I never typed in the database. It doesn't touch the database. It is done in the server side on in the server service layer to be specific before the entity is ever saved. So there is no path where the plain text password reaches the disk. Right. Now let us go back to our UI and let us test the network tab where I should log in by the freshly, you know, let us say I was shift at the rate email.com and the password is 1 2 3 4 5 6 7 8. So when we try to sign in, this should give the request and we will then see the JWT token whether it does or not. So right. So we see this login request, right? So the backend, the login endpoint looks up the user, compares the submitted password against the stored hash using the bcrypt compare function, never direct a string match, and if it's valid, it signs a JWT. So when I try to see, so when we see the response tab, we get the token, right? Here's the actual response. A signed JWT token plus the user sanitized profile carries the user ID and role and name, which makes the role-based access control possible later, right? We should also see the shared token stored in the local storage. Let me also show you that as well. So when I go to the local storage, we have uh, the front end persists that token in the local storage. Every subsequent API call attaches it automatically via an Axios interceptor, right? I don't manually add the header anywhere in my components. It's centralized in one place and in the code, right? Now let us understand about the guards and protected routes. So this is the real data that we have from our database. This is not something local storage or mock data. So it is live data pulled from Postgres, not a placeholder content. So I can also show you that again by, network tab. And when I reload, you should see the API calls being hit. And if I just try to check any of the, let's say the today's appointment, right? So if I try to see this, this is the response we are fetching from the live database. So this is the get request where it, uh, so here comes the authorization bearer. Every protected request carries this bearer token on the backend. A JWT guard intercepts this request, cryptographically verifies the token signature and separate role guards, check whether user role is allowed to hit this specific endpoint or not. For example, only because we logged in as doctor, we can check these today's appointment request, right? If I try to open this URL on the uh, unregistered or unauthorized, so if I try to access a protected route without a valid session, no token or an expired one, the app redirects straight back to the login page, both on the client and rejected server side with a 401 API that is called directly, right? And this was the full working skeleton, registration, secure hashing, JWT issuance, and enforced role-based protection running against a live Postgres database. And thanks for watching.